Yeah, so I thought these are actually negative numbers, which is not good. I want to figure out how that happens. First I have to get my music in order. This is... fuck off. Can I not get music from... here? No, good music. Right, so... why does this happen? It happens a lot. I need something that reproduces to debug this, I think. So let's start with trying to find a board where the first move already gives me this. That is the first of all possible moves. So I just set a breakpoint here. And we try only out one move. Plus, even the first call to new mines would be nice. So maybe just break out here also immediately. Does that print anything? Entering calc new mines, that was a thing, right? So that doesn't look like it. Error gives me negative numbers. Nope. And that one does. Already here. So this is the first move. When we click it. And then click empty again, click everything around it. And then we calculate new mines for the first time. It results to new empty ones. No, click mines, sorry. These are all mines. Then we click those and then it's wrong. Clearly it's click mines that does it. Yeah, that's the one that does it. And this is also the first time click mines is happening. The board is very large. Let me try to use a small board. See if we can reproduce it with a small board as well. F's are all over the place. Okay, I need click mines. Here's a click mines, and then it's wrong. Yeah. It's known borders. And here known borders is that. Totally different. Let's put a breakpoint there, but oh wait, we've put a breakpoint here. But I want to reproduce, so we use this as the seed. Okay, we're clicking these mines. Something goes wrong then. The known mines are four times 0. So I don't know any mines. Should have been printed. Yep, known mines are all 0. So if you do this, then afterwards, so obviously the known mine should be equal to clicked. You can also print clicked. Clicked should be this. I think this is the least significant one, or that's the least significant one. Okay, this 0 here is probably that. So the last array element is the one at the bottom. So that must correspond with this one. And then there's lots of zeros in the end. So the least significant is here. That means oh, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 4 is 40 bits. 4 bits is the same as 1 hexadecimal digit. So I might as well say 10 hexadecimal 0 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then 1, 1, 1. And then 3 more zeros that are not visible here. And then 2 zeros, that's these 2 zeros here. And then a 1 and so on. So this is that thing indeed. So now you know how to understand it. This is the array index 0, array index 1, array index 2 and array index 3. And there are all hexadecimal digits, where this one is the least significant one, and that's the most significant one. What we do next? Print. Hello, hi, Jerome. No, it's not reacting to anything. I'm just analyzing the game basically. So I have to, any input that I would desire so far has to be hard-coded. Okay, I just executed this line. So now known mines must become, it was all zeros, so it should now be equal to clicked. Now that looks indeed equivalent. Same. Well, that one worked. And that's all it does. It cannot be clicked mines. That's not the reason why things go wrong. Okay, do next. Now you see the known mines that we just said is being printed. Grid wasn't changed. This is all the vectors that we have, one vector representing a full board. Yeah, okay, I'll just have to step through the code, I'm afraid, to see when it goes wrong. Calculate new mines. That's probably the one that goes wrong then. So we created a Boolean vector called known from known empty. And known empty was this one. So there's just these 9 are known to be empty at the moment. Doesn't contain no mine, that is. So we should be able to print known mines first. And that is saying why does it look good? Oh, I'm printing known mines, yeah. Wait a minute. Known empty is we created it from known empty. I wanted to print known empty. That's better, yeah. So we begin with a 0. That's these 16 zeros. And then we get 3 zeros here, and then 3 ones. That's those 3 ones. And then 5 zeros. 1, 2, 3, 4, 5. 3 zeros. 3 ones, I mean. 3 ones. And then 3 zeros. What? Yeah, I only see 2 zeros here. Oh, I'm an idiot. Yeah. The least significant one is here. So I have to do the other way around. Those 3 are those 3. And then those 3 are those 3, and then those 5 are those 1, 2, 3, 4, 5, and then those 3 are those 3. And we have 2 more. These are 2 zeros in front of it. And here 2 least significant ones that, so we get 3 and then 3 ones, 3 zeros and then 3 ones. And the rest is 0, and then again 16 zeros. It's more like me trying to read this correctly, because it's just printed here, and well, that is just that. So, but I'm getting better in it. Now we do an OR with the known mines. So we get an OR between this and that. Right, is that correct? Eight, 9, 10. 8, 10, yep. Now we get 3 ones and then 3 zeros. And then this one, 2 zeros. 1, 2 zeros. 4 ones. 1, 2, 3, 4 ones. And then you get 4 zeros. 1, 2, 3, 4 zeros. Yep. And then again 4 ones. 1, 2, 3, 4. And then that one there is starting with the least significant ones. 3, 3, 1, 2. 3, 3, 1, 2, 3, 4, 5 zeros. Oh yeah, that's here. 1, 3, 4, 5. And then again 3 ones. These 3 ones. And the rest is 0. Yeah, we should not work on this too long. Just maybe today is the last one. Depends a bit on if what I find is super interesting. Still sleepy. Okay, now we get a negation of that. Hopefully that works. Oh, wait a minute. The negation is not working. That gives me the f's. It's not a negative number, it's just a full negation of the vector, while what I meant is a negation of booleans. Oh yes, it's on GitHub. I didn't do a. Let me do a git commit. So I think, and then I'll give you the GitHub URL. To understand what is going wrong here, though. Okay, so the operator not is not working. Okay, well then I don't have to continue debugging, I think. Oh, I just pushed that, so that should contain. Yep, everything. So the source code is in the source. This is all the files that I have at the moment. But this one is broken because vector.h operator not. So I already see it here. Tja, what a nonsense. What a nonsense. I'm subtracting the Boolean values from the Boolean mask. Oh, wait a minute. Actually, that should work. Why doesn't it work? No, I have to put a breakpoint here or step into it. Okay, we'll start over. Where did I set my last breakpoint? Solver something. So this is a vector with all ones everywhere. So this should be 16 ones. 1, 2, 4, oops, 4, 8, and this is also 8. Yeah, 16 in total, and that 4 times. If I subtract this from that, and this should be a Boolean vector as well, of course. What's this? Yeah, that only has zeros and ones on the hexadecimal digit places. That's why it is a Boolean vector. So that should not give me anything negative. 1 minus 1 is 0, and 1 minus 0 is 1. What can go wrong? I'm going to do next, I think. Is that really the problem here? Print inverted. Dang, that looks like correct. That is correct. There's no F here. So then where does my F come from? So weird, man. Unknown is still correct. I mean, it's a Boolean vector. Just ones and zeros. Okay, and then we explode that to next. Oh, that looks same. All the hex digits now should be between 0 and 8 inclusive. So we have a 0 that doesn't border anything. We have an 8 that borders 8. Unknowns and stuff. Borders unknown. Mines needed is known border minus known mine explode. So this is the number of, this is basically mines explode, and this is known mines explode. So this is always smaller than that. Really, definitely should be. So this also cannot be negative then. Mines needed. PX, mines needed. Loads of F's. So this went wrong. Why? Wait a minute. Known. Wait a minute. No. What did I just do? Known borders. That's known borders. Oh, and I must. Yeah, I cannot use the answer in finding the answer, so I cannot use borders. But I was thinking about borders. Borders is mines exploded. Known borders is not mines exploded. It's mines exploded ended with the non-empty mask. So that has a lot of zeros in it. And therefore we get negative values here. That is not good. Well, if I do a subtraction that gives an underflow, then we influence values outside the square, outside the element, so that's definitely going wrong then. So in order to make sure that we're not getting an underflow, I should fill everything that is unknown with just 15 and F, just all ones, so that I can subtract whatever I want. So then I need a mask of that is only valid when this is set. So we have to convert that to a mask. So that should become a lot of things. What to do? Let's not worry about the speed. Let me just write something for now. So I need let's make a new copy. I need an unknown empty mask. Known empty, and then not that is unknown empty, and then to mask is the mask. That should work. And here I can do OR with the unknown empty mask so that we don't get underflows. Still not mines needed though. So then after subtracting that, I want to remove that mask again. So yeah, that would be an AND with the inverse of that. The known empty mask. Mask is not a boolean, it's a vector. Oh, I don't have a tilde operator for vector. You gotta be kidding me. Type. What's this? I don't think I have an operator equals yet. Oopsies, we are dead. So we're marking these things as empty, and then one of them is a mine. One or more, that is a mine. And that is a mine. And that is a mine. You clicked on 3 mines at once. How did that happen? This one worked. Just clicked on 8 mines that were actually mines. 1, 2, 3, yeah, all mines. Not bad. And is it also true that we could know that there were mines? We did click on these 9 apparently. These 9 are known to be not mines. And then this one borders on 5 mines. It says, of course, here the 5. And it borders to 5 unknowns to begin with. So yeah, all 5 have to be mines. So that's that one. And then this 3 comes from that one, I bet. That would be this one. This one borders on 3 mines, and we can see that none of the known things are mines, and the 3 unknowns must be mines, therefore. Yep. Now we do calculate new mines again, or what? Click mines. What is definitely missing here is already calculate the empty ones. It says calculate new mines, and then we click on empty. Well, maybe it just doesn't print already calculate empties. Calculate new empty. It's not printing it. So calculate new empty. Click empty. These, and that's wrong. So now I want to add debug output to calculate new empty to show how we got this because it's wrong. Uh, So yes, this is the output that we click on, and it is wrong. Known borders, which is this one, is still the same thing. Good. Known mines, which is just this one, it's still the same thing. Good. Known mines explode. Well, that means that we add 1 to everything that borders a mine. So that becomes 1. That becomes 2 because it borders 2 mines. That becomes 3 because it borders 3 mines. And again 2, 1, 2, 2, 3, 1, 0, 1, of course. 3, 3, 5, 2, 1, 2, 1, 2, 1, 2, 3, still 3, 2, 1, also 1, also 1. Yeah, 2, 3, 1, 2, 1. What is this one? 1, 1, 1, 2, 1, 1. Totally correct. Explode works. And here we go to the F's again. So that's the reason that it fails. Mines are needed is known borders minus known mines explode. Yeah, same problem as before. I have lots of unknowns, which are all 0. And then if you subtract something positive from it, you get negative values. So I need to do the same trick here as I did before. The subtraction is not good. maybe I should store f's in known borders to begin with. Now I have all zeros. What if I just store f's in everything? Seems like a better plan anyway, because now this 0 is a bit unclear compared to that 0. And the only reason I know that these two are different is because I have this mask. But an f doesn't mean anything, because you can never have more than 8 in it anyway. So anything, oh, I could also store 8 in it, so at least as long as I don't get an overflow. But an f might even be more clear, because then it's not equal to anything that is valid. It's just not a valid value. Okay, I'm going to change the format of known borders. We change everything that is now unknown, so that is equal to 0 here, must be an f, or must be all ones. That's a big change. So known empty is all zeros, aka all false, because of default constructor. Therefore, this one must be constructed in a way that we get all ones everywhere. How to do that? Need a constructor that fills everything with ones. I think value should do. This one, it just sets value. Yeah, which is equal to value mask. I think somewhere I need that, some value mask. Value mask is not defined. Well, something from the base class. Yeah, vector.h. No man, solver.h. Good, 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 good. Good, just printing it. Click empty. Known borders. Or what borders and known empty. Yeah, that's not how it works anymore. So this bitwise-OR only works if the unknown things are 0. Hmm. Yeah, I have to get the values, the new values, from borders. So I have to do borders, these are all the values, and I have to do an AND with a mask. Let's call this mask to make it a little bit more clear. So there's no way around this bitwise AND here with the mask to get that value. But I no longer can do an OR because we have all ones here, and then you do an OR that just stays all ones. So really I want to use something that changes ones into zeros. Where this contains now the zeros as being new information instead of the ones. So I just have to do an AND. And then it's not slower. It's just exactly the same thing. Yep. That works if it is F's, but it also works if it already has the value of the borders. Then it's just X and X is X, or F and X is X. This is just printing, and now here we do subtraction. So that went wrong because it gave us an underflow, and that no longer happens. But wasn't this the one that went wrong? I think so. Let's do this one last. So this one was already fixed because I ordered with an unknown empty mask. But that one is a change that I no longer need, I think. Because I just added that by default anyway. So the unknown empty mask was just to prevent the underflow. And underflow is no longer happening, so I cannot just remove this. I still have to end it with the known empty mask, yeah? So this can be deleted. Or I don't have to end it with an empty mask actually, because here we just find everything that equals 0. So I do not end it with a known empty mask. Now I end up with F's in all the other fields. Yeah, F is larger than any other value that can come from explode, so it's never 0 after subtraction. Therefore, that will work without that. Yeah, the only reason I did this because it didn't exist, but I think it just should exist because that reads better. So let's add that operator. Mines needed is known borders mine is the explosion of the known mines. Known is the OR between known empty and known mines. Borders unknown is the explosion of not known. Needs all means everything that is unknown must be a mine. Is then equals to borders unknown minus mines needed. I need known for that. Let's put this one here. Equals to 0, and then we need a clear. So I'm also going to do this. Just come on, man. Known. Might as well do that here. Known or edge. Remove known or edge. So you can fix this one as well. So now this does not underflow anymore. Just print it, and then we do mines needed equals 0. So it's the same thing. Now it just works. That was a good change. Do an AND here, known empty, I think. Yeah, I guess. Oh boy. So I have that operator, but not for a bool vector. And it refuses to convert a vector to a bool vector. Just if so we want to do this, then I just have to... Oh, I'm not using that. Sounds like more fun because they're all Boolean vectors, right? That's a Boolean vector, that's a Boolean vector. An edge is a Boolean vector, yay. Yeah, I guess it makes more sense also to use that. And then here we have the same. Ja. Value mask was not declared. Solver.h. That's okay. It's kind of weird though that value mask is not highlighted. Assignment to read only. I keep making these mistakes. Unbelievable. It's the second time today. Wait a minute. Result. So good that the compiler is so type safe, right? Now what? No matching function for call to bool vector. Oh, not again. Does this return a vector? Non-empty is the same thing. Yeah, sorry. No problem whatsoever. That's also a boolean. And now we have warning inline function used but not ever defined. Why is it called inline then? Because it's const expression. Do I have to put all const expressions things in the .gxx? In the .header, I mean. Apparently. but well, then what happens if I put that here, down here, and then say, well, you say it's in line, tell me about it. Yeah, gotta learn something new then. We clearly have a 100% failure. Now it thinks that everything is a mine. Oh my. And this is also very nice. Oh wait, this is just intermediate stuff. That can't be right. No, 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 no. Really? Yeah, well, I don't know. Not working at all. What is going on? Wait a minute. It's all zeros. That's what's going on. The whole idea was that I changed this 0 into an F everywhere. And clearly has not happened. Why the hell not? How is that possible, man? Known borders. That's what I changed, right? GS, known borders, yeah. Value mask. Grid. Okay, let's debug our way out of it. Hold on. Okay, which solver? GNU debugger, the solver, break in main, run. Now let's list it. So what you're going to do here in main is initialize debug stuff and the random number generator, then create some random grid. And then immediately create a possible first move that should hopefully still work. Where's my solver? Here, solver is not created until line 33. Let's set a breakpoint on line 31. Continue. So this is my mine field, and I'm going to click that one. 1, 2, 3. We're going to click that one. Why? Because that is the only one that gives me a 0. 0 adjacent mines. My music is really bad. I just one. I just want one thing. That's no vocals. I can't do that. Okay, we're going to click this one. Next. Print move. 28 is probably the index of my move then. Step solver. Now we're going to construct known borders with value mask. Can we print value mask? There is no field name value mask. Well, you sound like GPT-4 because there is a field value mask. Can't they write a compiler of? Sorry, this is a debugger. Write a debugger that says, I think there's no field named value mask, but I'm probably mistaken because it's literally in source code. Okay. Yeah, I could do a step, but then we're gonna step into that. So annoying. Maybe you can intercept the constructor. Known borders, known borders, known borders, known borders. Known borders. Known borders should be a vector. Just vector.cxx. Right, I just moved that thing to the bottom of the H file. Just vector.h. Jailbreak 153. Continue. No, the value mask is 15. That's correct. Something. And this is known borders. Indeed. And we're going to run I from I till calls times rows. And then call set value I. Step array index bit shift. Clear something. It's nothing to clear, everything is 0. Or maybe it's not even defined actually. It's undefined. I'm doing something on an undefined value. Next. Maybe there's a smarter way to write the constructor, but it still should work. And now we do an OR. Okay, bit shift definitely going to be 0. And then value is 15. And now we do an OR. And now my data array is ending on an F. Okay. Now we do next step, next. And you have 2 Fs. I see that go completely right. Well, we ended with all zeros. I can already stop. This looks like it works. Let's do next. For a while. I think I runs to 64 here. No, constant. Probably actually. There's no call. Oh, there's actually a calls. Rows. Yeah, 64. That's a bit much. I was about to stop. Really? Yeah. That was not working. Run. Yes. Continue. I created my... Oh, I have another breakpoint here. Yeah, so now I want to break at 156 and continue. Print this in hexadecimal. All F's. So that one right. Why the hell is it printing all zeros then? Maybe I'm not printing it correctly. I think might not print it correctly. Let's look at the printing of it. No, that cannot be it. Why did I leave my debugger? Let's put a breakpoint here. Known borders is MG. Possible, isn't it? Known borders. Known borders is all F's. And then we are here. And then I do next. And that's all zeros. So click empty fills everything with zeros. Okay. Clearly there's something going wrong. Something was going wrong there. Then yes, next step. Clicked set value. And click empty. And construct something. I just want to go to click empty. So we are click empty. Assert known empty or is clicked. Known empty mask. Known empty to mask. Known borders. All F's. Yep, I'm an idiot. I knew it. So I changed this OR into an AND, but no, that was not it. And we need to do more work. I do need to somehow invert this mask. What about that one? I think that one works. Now we have all F's. Yep. So everything that is not known empty is now an F, and then where we know that this one is empty, then the known borders are given, and the known borders there are 0 bordering mines. Which means, of course, that everything around it is not a mine, so it can be clicked. So known borders, yes. It's not something before that, no. Known borders is that. Known mines, you don't know any mines. Known mines exploded, still nothing. The mines needed is known borders minus known mines, aka this should be equal to known borders, which is when is and was that. Has all the mines that it needs is wherever that thing is equal to 0, which is only in this place. That's the only 0. So only this square borders on all the mines that we already know, meaning that the rest is not a mine. All 8 are not mines. Maybe there's some junk, so we're doing an AND with known empty here. Still the same thing. And clear is known empty. That looks like junk. There's the clear junk. That's pretty clear. There's all is this 1, so you explode that, we get that. Now you know what explode is. If this is a single 1, you get that. Everyone does that. And then this is converted to a boolean by stating, well, make it true where it is 0. So now all the zeros are 1s and all the 1s are 0. And then we do not that. That is again the inverse. So that would be say that this was a 3 and then now it's a 1. So to convert it from something that was exploded to booleans. And then we clear it. For a mysterious reason that looks sane. Even though the clear was junk. So that's where you want to click on. Well, totally correct. So now known empty is that, and known borders are F everywhere except in that square, which is equal to the number of bordering mines. Get the same thing again. Still don't know any mines. Still 0 after exploding, no mines. Subtract that, still the same thing. So mines needed is still only 1 for the 0 that we had, because you don't know any mines. I guess that's a dead end. So I do the same thing. Something wrong with the clear. I mean, now the clears the right thing. There's nothing we can. No, it's not 0 because we already had that one. So it cleared this one. Actually, it cleared all those things because we already knew that. But then why is clear being so weird? Especially these are weird. I think this is all cleared maybe because we already know that. And then these are cleared because we want to end up with a boolean. But then the edge should have been F's here. So if there were F's here, then I would not have said it was junk. Totally something went wrong here with the 1. A 1 instead of an F. And then we enter calculate new mines, and that fails, and this is the mines that you click on, and that was the assert that we had. So I just debugged something that already worked. That was find the empty stuff. Calculate new empty. Only flex squares in mine that are really mines. Okay, now something goes wrong with the mines then. But I'm not going to give up on this clear is thing. Maybe just the edge is wrong. Yeah, man, these are booleans. The result should be a boolean vector. It isn't a boolean vector because it's full with F's and E's. Something is horribly wrong. So let's print the edge anyway. Maybe it's just the new operator that is wrong. Seems likely because I wrote it. Must be wrong. Edge looks totally not correct. Edge is wrong, I guess. Edge is totally wrong. Yeah, if I'm doing an OR, a boolean OR with something that is already fucked up, then you get something that is fucked up. So maybe my operator works, but edge is definitely wrong. Let's find that boolean operator anyway. Yeah. Yeah, this just assumes that the values are same, but they are not. They should work. Where does edge come from? Edge is the inverse. Generate inner. Yeah, that's not working for a boolean vector. So I should have used a not. But on the other hand, generate inner returns bool vector also. Yep. Okay. that should be all zeros, and then call is 1 less than calls minus 1, row less than rows minus 1. Set value index call comma row comma 1. That should be all ones in the inner. And then return edge. Well, it's not an edge. It's inner. Yeah, then maybe that fixes it. I use operator not. Although you would say the tilde should have changed. This still should have been an F instead of a 1. It's really weird, man. No cons expression. So cons expression is like a virus. Yeah, that is a cons expression, and everything is a cons expression. Why not add cons expression when you can add cons expression? Const expression. And here we have const expression. And I'm just continuing with all of them. Shift. Yeah, why not? Might as well call everything a const expression. Okay, now I'm tired. Not marking more. Okay, now the edge looks sane, and so does the clear. You just want to clear the edge and everything that's known. And minus all was that explode. Yeah, everything is now looking good, sane. And then we do the mines, and that fails. So I probably should now add all the debug output to that one, so we can also check that one. This one is way shorter than the one above, so that's good. Known empty. No, we just copy stuff and then paste it, and then known mines, and we want to print known empty as well. Empty. And then here we print known is known empty or known mines is known. Just calculated that one. Yeah, let's do it step by step. So next we print not known is not known, and then we print not known dot explode is what I just calculated. That's borders unknown. Mines needed. Did already print a known mines explode? Nope, it didn't. DC notice known mines explode is known mines explode. And then there we get no is well, what we just calculated. And then we get needs all I thought it was short. It's not really short. Needs all explode is needs all explode. Equals 0 is 0. And then negation of that and then the clear of that Cubicles. Hello, man. Why is it good to see someone streaming and coding every day for hours, by the way? Explain. Oh, sorry. Hi, Durang B asks another question. So you're annoying, but can you explain if you just remove pragma 1, you mean once, in the vector, what would happen? Well, then it wouldn't link anymore because I would get duplicated definitions in different compilation units. I say that, but let me think. No, it's not true. Sorry, totally different thing. Then you would get a duplicated definition and in a single translation unit. So the duplicated definition, really. The duplicated declaration. So you define a class and then later on you define that same class again, and that doesn't like that, the compiler. See at the bottom, yep, that's the result. Calculate new mines. Known empty is, this is the title, right? I mean, it just here's printing of the board starts here, and it starts with printing the name of the thing. So known empty is has a title, known empty, with a space, no underscore. Yeah, I agree with that. We still don't know any mines. So known empty or known mines, known empty or known mines is still the same thing as known empty because we didn't know any mines. The inverse of known, which you just printed, is this, clearly. And if you explode that, then I would say we have a lot of 8s because a lot of things. I am not happy with this 4 here. You would say this thing borders 1, 2, 3 things, not 4. The 5 is correct though. 5. 5 and then a 6. What do you mean? Bloody 6, man. That's 1, 2, 3. Why 6? Oh, of course, yeah. That's why I have a border. It's also counting stuff from the other side. So this thing thinks it's adjacent to that one. And then diagonally as well. So just all the things in the edge go wrong. But that doesn't go wrong. This is an 8 because 1, 2, 3, 8. 8, 8, 8, 8, 8, 8. So these are all 8s. And these as well, all 8. And then here we have a 7 because, well, that's that one. So that's 8 minus 1. And then we have, for example, here something that is bordering 5 things. So that would be that one. It's totally symmetrical. You get 5, 6, 5, 6, 7, 6, 5, 6, 7, 6, 5, 6, 7, and so on. And then here we have 5, 3, 5, 3, 5, 3, 5. So the 3 here is because 1, 2, 3, and the 5 here is because 1, 2, 3, 4, 5. So yeah, totally correct. Explored correctly. Known mines explode, still 0, of course. Known borders minus known by minus known mines dot explode. That would be still known borders. I think known borders was already printed, so that's an F where we don't know, and then these are the one that are actually known. Needs all. Totally not correct. Mine's needed. Oh, maybe it is correct. No, it's not. This is what we just showed. No, we didn't. Something else. Borders unknown. It's not printed. And mine's needed is also not printed. It's not mine's needed or something. The result of this should be a true value, aka 1, on every square that needs mines on all the unknowns in order to fulfill its thing. For example, this one in the middle has zero mines that bordering it, and it has 0 remaining things. Therefore, everything that is remaining, which is nothing, should be a mine. I mean, whatever. This one says I want to see my known borders. This is a known mine. We don't know any mine. So this thing says, I think this is the known borders. So it borders 2 mines. This thing borders 2 mines. But it borders 3 unknowns. So we don't know which one is the mine then. There should be a 3 before it became a 1 here. This is just wrong. That one is a 3. That should be a 1. None of the others should be. Well, actually, that one should be. And it isn't. Oh. Yeah. No, it should be previously we saw 5, 3, 5, 3, 5, 3, 5, 3, 5, etc. What we want to do is subtract this from that, and then you get a 0 here and a 0 here, and the rest is non-zero, positive. And then only those 2 should be a 1. So this should be a 1 and that should be a 1. So this is so totally wrong here. And I didn't print enough to understand it. Yeah, and then explode something that is wrong. Then you get something that is wrong, and that's the reason why it fails, I guess. I mean, the rest is, well... What to do, Okay, so printing these values as well then. I have a needs all. Needs all. did print them. What is unknown? Mine is mines needed. That's this one, which is printed but not worth a name. Oh, this, when did I do this? Same problem here. No, no problem here. That are even compiled. Maybe it should not even have made a difference now I think about it. If you have a parenthesis around something with a comma, then the value of that whole thing is just the last argument. So I said equals, parenthesis open, something, comma, blah, blah, blah. And it just assigned this to that, so that it's not even doesn't even make a difference. Anyway, now we're printing it. Mines needed is mines needed, so I have this one. And the borders unknown is printed. Equals 0, is needs all. Print needs all, is needs all. It's calculated like that. Yeah, so now I should be able to see it. It is borders unknown. Click that thing. Minus mines needed. That's that thing. Oh. Now subtracting something with f's. Why is mines needed and having f's everywhere? That's not correct. Yeah, these are the smaller values. I want to subtract them from this. That's totally true. This looks okay. But the f's here get in the way. You have to get rid of those f's. Those mines needed is the wrong value. Mines needed must be I remember removing that, and the reason that I removed it was because I said we don't need it because we do an equals. Well, that's not true if you get an underflow here. So in order to avoid the underflow, we just have to remove all the f's again. So that must be ended with... I really don't care about this. Away. This must be ended with a mask. And now I'm doing OR. I said end. And the mask must be the mask of known, empty, right? No, just known. Known empty. Known empty to mask. Something like that. Yay, that worked. See if we can find that back where we were last time. So you can see now that it works. I just finished everything, so Click empty, calculate new empty. Calculate mines. Borders. Okay, that's where we were. Yep. Yep. So now we get just these two. And the one in the center, but well. So we now explode those, then everything that is becomes a 1 or a non-zero even, that is not known yet, is a mine. So explode this, you get lots of 1s here. And then equals 0 means that it is all the zeros now. All the zeros are mines as long as they were not known before. So we invert that. Equals to zeros. All the 1s are mines if they were not known before. So we do the clear. And now you have left the new mines. We click that, doesn't assert, so that worked. Let's use the last state here. Not much, known empty, and known mines. Not everything is known yet. So it just stops. New mines. Calculate new empty. Calculate new mines. Yep, nothing to do there. So we have to start guessing in this situation. Is that true? Is the question. Yeah, I guess it is. Okay, so let's reintroduce a random generator. And we just do a few of those things. Never, oops. I have a search, so everything it does is legal and correct. And it always finishes without asserting. Let me make them a lot bigger. Say +8. God, never solves it. So having a lot of mines is definitely not prey. I want to see the state of the solver at the end, not this. So when we're completely done, oh, I'm doing just one move now also that. But okay, let's just print the solver here again and then break. So just one move. Yeah. Yeah, it's almost nothing, you see. Almost nothing. It knows that these things are mines and these are not mines, and then you have to guess. It's not solvable. Oh, this is even worse. Just here in the corner. Okay, I want to have one that has a pretty big amount of stuff solved. Should happen at some point. So this solver is not guessing, right? It's just finding every square that it knows for certain is empty or for certain that it is a mine. And then the program stops as soon as it cannot find any field anymore that it is certain about. It can be certain about. As you can see, it stops almost immediately. This is one of the biggest guesses that worked that I've seen so far. So I think the next step is to, for sure, determine if we solved everything. And I guess we solved everything when these two ORed together is the whole inner square. If not, solver solved. So if it could solve it, then it goes to the next move. And only if every move results in a possible solution of the whole thing, then we exit without that break. Yeah, now I have to write that solved function. Solved on the solver. So the whole inner square is known, either minus or empty. Yeah, then it was entirely solved. So generate inner is defined in bool equals h, so I guess that will work. So now it says could not entirely solve. So I just generated a single board and discovered that it could do almost nothing here. So yeah, that's going to be the result every time. But it's random, so let's run and make a new one until we find one that we can solve entirely. So now I want to loop around everything so that we just generate the next board. I can keep the grid, I think. I can just call randomize on it. So let's do forever. Create randomize else. So here we do break. Then we are leave that infinite loop. Else create randomize and then start again. Oh yeah, I need to pass the random number generator. The random number anyway. Make run. And that takes forever. So let's reduce the debug output a little bit. I'll think that this is already working, so I don't need all those debug output can be removed here. Let's just remove everything. I don't need debug. Do not need debug anymore. I'm gonna so regret this if it doesn't work. Oh no, why did it? Oh, okay, I was almost saying it out loud. So let's do that. Git status, let's commit it, so I keep that. Git commit -a. Right, so what did I do? Basically finish it, right? Could not entirely solve. There's stuff in between that is still printed. First moves. Yeah, maybe I should just run the release thing. So let's just, I mean, I want to have it optimized anyway. Let's forget about debugging. And then the debug is also turned off. And that's printed to standard out. Solver utils. Let's not print this. Definitely not print that. Definitely not print that. And not that. Not this either. Could not entirely solve. Well, this we want to see, of course, but let's for now also print that could not entirely solve. That's going to be the bulk of the output. I just could not entirely solve, and then associating what it could not solve. Let's add an attempt. So this is also trying to find at least one that is, you know, it randomizes the grid here again. Even that is going to take some extra time, which you can definitely speed up. So that there is at least one possible move, and then let's call that an attempt. So I'm going to do now here plus plus attempt. Going to do an attempt, and then here we can print it. Well, we already did 100,000, but it's pretty slow. So let's try not printing this at all. Since it still did not assert, oh wait a minute, I have turned my inserts off. Well, okay. I was already convinced that it worked anyway. Now it takes forever, so we're going to make the fields again a lot smaller. I would like to have one that solves this. Maybe it will. Could solve this field without any guessing, and then it's not printing. But that's pretty fast. 526. Wow. Oh, wait a minute. What do you do? This one? Yeah, the solver is here. Inside. I just have to print grid, not the solver. It's called field grid. Mine's on the edge. Now, what is super clear, I mean, I'm generating this randomly with 50% chance that something is a mine, every field, but you see only a few mines. So as soon as you have too many mines, it becomes unguessable. You really need, yes, just really few mines. All the ones that are guessable have either very few mines or the mines are on the edge. Loads of mines are on the edge. This one has 4 mines that are not on the edge. This one has 2 mines that are not on the edge. 1 mine, 3, also 3, 3, 1. So 1. So as soon as you have, it looks like there's never more than 3 mines in the center. That would be amazing. Oh, that's a lot of mines. Not. Yeah. Okay. There's 1, 2, 3, 4, 5 not on the edge. That's a lot. There's more than 3. But the special case here is, I guess, that is sort of a pseudo edge. You just start here, and then you know that that's not. Those are not mines. And those are not mines. Well, it's a bit unclear how I would get past this point. So once you can guess this, you can guess all of those. Something like that, I guess. Yeah, no, I don't know. Still, looks interesting. 30,000. Okay, let's make him a bit larger, such that it still solves it, but just large. Let's not go too fast. 8 by 8. Yes. Not too fast, I said. Well, if let's say, yeah, I don't know. I don't know why this is already not working. By now I want to know for sure that it is doing something sane. Let's turn on my asserts. These asserts here. I'm thinking now I have them turned off. So if I add an assert here, false, and it just should not assert anyway. Yep, and then I want to find the right thing. I guess beta test. Yeah, that must be it. Beta test probably fully optimized, but has asserts on. It's 03. Well, I don't see a defined for end debug, so this should be working. I think, yeah. So, but still not. Shocked. Huh? Okay, that didn't make any sense. I thought it was better test should have my asserts working. Let's try relevant debug. Okay, now at least the asserts work. It's compiled with O2. I should not have debug output, so. Okay, so clearly the asserts never fire. That's good. I still can't find anything. I think this printing is slowing you down, just the scrolling of the screen. Maybe we should only print every 1000 or something like that. See if that goes faster. Yeah. No, 100 is equal to each 100. Yeah, it doesn't feel faster. Yeah, well, that's weird. It's just not doing it. Let's put one of these on 6. Can't increase it less. Yeah, the speed at which it is doing it, I'm starting to think that a random number generator might be a bottleneck. Because that thing is pretty slow. Let's just do every 1 million. It doesn't feel right anymore. Why the hell can it not solve 7 columns? Can it still do 6, 6? We're gonna know. Something happened maybe. I don't know what, but yep, that still works. What about 6, 7 then? It should also not be, but just rotate it. It should never work. Just as difficult as the other one. Yeah, and it doesn't work anymore. Cannot find it anymore. How? Why? Oh, this is so weird. We'll let it run till 100 million. Right, so that's, yeah, weird. Really, really weird. Something must be wrong. I cannot believe that. I cannot believe that I cannot find any that can be not be solved. Sorry, I cannot find any that can be solved without guessing. Why would it not be able to do that? Maybe I should hand feed the one that I know can be solved without guessing, and then see if it can solve that. For example, an empty field with just one mine. Well, an empty field, just no mines at all. That's 100% solvable. I mean, that might take a long time to generate, yeah, by pure chance, pure random numbers. So I guess all zeros was not generated yet after 150 million times, but is it really so unlikely? Okay, well, I'm done with it. I was just trying to help someone else, as you saw. I just talked to them. He asked on Discord in a certain channel, and I just saw that he left that channel. So I was kind of a little bit pissed. But on the other hand, I'm just doing it because I like it, right? So it just didn't really matter even. But right now, I don't think I should continue with this program, although I am, yeah, what's the word? Intrigued, that's the word, yeah. By the fact that we cannot find any solution at all for 6 times 7. I'm gonna try just to fill the whole thing with nothing. That should be solvable, right? Definitely should be solvable. So what we really want here is then to have a grid that has randomized, that just doesn't fill any mines whatsoever. If I don't call that, then it should be the case. Yeah, that's what it says here. I could solve this grid without any guessing. Yay! Because, yeah, no matter where you start, you just get no mines. And then you can click all the bordering fields, and there also say no mine. So you click this one, and then all of those, and then you fruit fill the whole thing. And that's about it. So if I do vector.h, I make this a 7, then definitely should solve it as well, right? Wow. Okay, one broken program. And now what's going on? It doesn't even do anything. Okay, the program is buggy, that's clear. Sol.cxx. Let me use this again. Just print it every time. I want to see how many attempts. Yeah, I mean every attempt should succeed. So why the hell does it fail even once? AKA on the first move. And I have to turn all my debugging on again. Exactly what I was scared of. I could use this div and then edit it. How can I get this div? It's just the div of the last commit. Okay, I want to revert everything that deletes something. I think even those, yeah, just all the debug output back. Let's not touch this or this whole file. Stay whatever it wants to be. Clearly I don't want to remove that one or change this. Well, actually I do want to change this. Let's even add those back. Maybe not that interesting though. No, that's not print solver while solving it. Or do I? Well, why not? Let's print that as well. And here's an attempt again. Did this one comment something out? Yeah. Let's do it like that. And then this one. But it might not work because this uses line numbers. It's annoying. Just add that one back the way it is already. Oh, it prints attempts. Yeah, definitely want to keep that one. Or no, maybe you want to take no, I don't know. Yeah. Well, let's keep it like that. And this, I want to keep that one. That's annoying. No, wait. Means that. Print that. Replace it with a minus. That should work. No, I'm an idiot. I don't want to change it back. What am I saying? Sure, that's better. Right, a source. Well, everything is in source, I think. So patch reverse minus p2 last commit or div. Should have worked. Right, okay, so it always fails, which is bullshit. I just want to quit completely after the first fail, even after the first move fails. Possible moves. Do the first move. Do something while moves. Not solver solved. All this false break. Okay, they should just terminate everything. I think I'm in main, so we're not. You're not in main. No, we're not in main. We're not in main. We are in main. Penalty if you don't do that is the last one. Then it must return at 0. Okay. Make. Solver. Attempt is 1. Failure. Why did it fail? Okay, now I also have to print solver, I think, to understand what's going on. What the hell? Is that a big file? Is that big? Nah. 85,000 lines. No mines at all. First moves, every square is good. Let's start with this one. Da-da-da-da. How annoying is that? Why is it showing it like that? Doesn't make any sense. Oh, because of all the colors. Yeah, I need. Oh, okay. Yeah, nothing to do about it. Although I have to make my font a little bit smaller. It's a bit too small. Also still small, isn't it? What is my default? That's where we were on. Yeah, the current profile. $16 points. So 15 points, 14, 13. You gotta be kidding me, right? I need 11 points to get this on my screen. That's ridiculous. Ridiculous. That's just a real bullshit. I have a better idea. That works. So we begin with this one, known borders, all S, this one borders nothing, therefore. Same thing, known mine, don't know mines, exploded mine, still nothing. Subtract that, same thing. Do some stuff, and then in the end, you should get this. Yes. Also that. I'll leave that just in the edge. As all explode equals 0. With the clear, yeah. So this is what we want to click on, and then we click on it, and then we have these are non-empty. Well, that should continue like that. Clear non-empty. has all explode. Okay, just says no mines clear. No, this doesn't make any sense. But okay, it does find the next one. So click empty. Yeah, okay. Click on those. Click on those. The next one should be zip zip. Yep. And the next one should just be this one. I wouldn't know why not. And it is. And then we clicked on everything. Now known empty is just completely full. So we solved it. I guess I did something wrong in my function that determines if the thing is solved, because this is totally solved. But okay, we continue. Calculate new empty. And now it should conclude that there is nothing to click anymore. Yeah, so now there's no new fields that we can click on. And then it's still not satisfies and want to know if there is maybe a mine that we can click. And that should also not exist. All nothing, okay. And it does again and calculate new empty. It's really strange actually. And again, new mines, why? Also nothing. And now we go to the next move. Oh, right. So it did solve it. It thinks, okay, yes, we solved it. Okay. Okay, let me just scroll till we see those things here. Oops. And that one, that also fruit fills. Next, and the last one is the whole edge. And that should be solved, so we get nothing. Click nothing. That should never happen. but it is already solved. I have, as of yet, still no clue why this is not going to say that it could solve it. Maybe you have to scroll to the bottom. Oh, it's a bit big. Just jump to the bottom. Let's go 10,000 lines lower. 1, 0, 2, 3 down. Begins now we're there. Okay, 5,000 lower. 1, 2, 3 down. No, that didn't go very fast. So just 10,000 down. Still only here, really? Going 10,000 more. 10, 2, 3 down. That's the last one, finally. And flute filling. And more, then we get that one. And that one. And the last row. Yep, and now it's all known again. Therefore, what happens then? Known empty all zeros. What? Click empty. I don't see any one, just only zeros. Click this all zeros, and here we do not clicked is empty, and it did not fire. Why? Charles, I'm trying to debug why it cannot solve a completely empty minefield when the field is 6 times 7. I think the reason is that it doesn't fit in a 64-bit integer. Which means that if I would make it, say, yeah, then always have to be powers of 2 then. I think that the problem is that my data array now is larger than the actual board. So it's testing bits that are outside the board. Therefore, it might return false, while the actual board bits are all 0. How to make sure that I do not do that? Yeah, so I'm bored of 6 times 7 with an edge around it. Is 6 plus 2 is 8, 7 plus 2 is 9. Is 8 times 9 is 72. Minus 64 is 8. So I have an array of size 2, and only the first 8 bytes are being used. And this is the only function that, or is it? I mean, these never want those bytes to be used, maybe. It just should always be 0. So which function makes those bytes larger than, well, unequal 0? Well, that happens a lot, I think. That happens in my constructor even. The vector constructor here. There's another one, equal 0 bits. It's just not working at all, man. My program is one big bug when there are unused bits in the array. I should eat. It's 9 o'clock. I think I just should stop. I just had a bright idea though. Vector, or nah, probably vector template. It's like my window small again. What is this? Feet. I'm going to use a vector template and then add well, this should be a mask that has the most significant bits set. No, the other way around, I think. The most significant bits must be 0. That the excess bits must be 0. So that simply that's all ones. Shifted left excess bits. And then I can call a function clear access. Did I write access correctly? Guess so. There is no longer access actually. This is no longer an access because it's the inverse of the access mask. And I have to keep that naming correct, so inverse. Right, so now I can call clear access bits whenever I want. Is that the only non? Yeah, this is implemented here. Except that one. Good. Yeah. So make sure that the access bits are not set every time I print something, and I don't have to print them. I just want them to be always 0. It's not how it works though. I have to do it per row. So every time I print the last row, it's not the last row that we print, although that doesn't matter much. I just want to test it only once. Oh, well, let's say only a third after we printed the last one. And then we check that the most significant thing and some mask must be equal to 0. So the mask is the inverse of the excess bits inverse. Was that the thing? Excess mask inverse. What the hell? Oh. Time to stop. So much. Not every time the same error. Clear access bits. No. Oh, non-const expression. Really? Why the hell does that not assert? Okay, now I'm stumped. Well, no. No. What's going on here? What is going on? Okay, I had enough. It's late. I'm going to do something else. And I'll look at it later, I guess. Tomorrow or something.